Yeah, welcome to the third lecture of Research in Financial Markets. The paper that I would like to discuss with you today is entitled Betting Against the Correlation, Theories of the Low Risk Effect. As you see here, so the paper is written by Asness, Frazzini, Gormsen and Pedersen. Two of the authors, Frazzini and Pedersen, they published in 2014 already a paper entitled Betting Against the Beta. Yeah? BAB, Betting Against the Beta. So this paper from 2014, in this paper they proposed a factor, or respectively an anomaly or a trading strategy, that buys low beta stocks and short sells high beta stocks. This strategy is updated every month, so it's a monthly rebalance portfolio. Yeah? And what the authors figure out was that low beta stocks outperform high beta stocks. Yeah? So in this paper, Betting Against the Correlation, they basically break down the betting against the beta factor in a correlation factor and a volatility factor. So BAC, betting against the correlation, and BAV, betting against volatility. So the beta of stock I, we can basically decompose it. Let's decompose the time series beta, the estimated time series beta, TS stands for time series beta of stock I, can be decomposed into the correlation between stock I and the market times the volatility, estimated volatility in this case, of stock I divided by the market volatility. So obviously the betting against the correlation factor or strategy focuses on this correlation part of the beta, whereas the betting against the volatility obviously targets this part, the idiosyncratic volatility of stock I. So the strategy betting against the correlation aims at buying stocks that have a low correlation and finances this position by selling stocks that have a high correlation. Yeah? Similar to the betting against the beta factor. Yeah? So we have a portfolio of low correlation minus high correlation stocks. Whereas the betting against the volatility factor, it is basically a combination strategy. So we have basically two different strategies here. We have on the one hand, the literature has been discussed, the so-called Smax strategy. Smax strategy, which is in essence a trading strategy that buys stocks that have the lowest average of 5 days maximum return in the previous months, and is selling those stocks that have the highest average of 5 days maximum return over the previous months. So this is called Smax strategy, and the literature has also discussed another strategy that is called the idiosyncratic volatility strategy, or IVOL strategy, where you basically buying stocks that have the lowest idiosyncratic volatility in the last months, and short-selling stocks that have the highest idiosyncratic volatility. So what this strategy is actually doing is, what you do is you regress the excess returns, let's say the excess returns of each single stock in your asset universe. Yeah? You have an intercept term here. You have the market factor in excess form. You have to add, of course, here beta. So alpha I plus beta 1i times the excess return of the market at time t plus beta 2i times the S&P factor at time t plus beta 3i times the HML factor at time t plus the error term, the error of asset I at time t, or the residual. So what you basically then take is you do this for every month, yeah, for all these 22 trading days of the previous month. You basically run this on using daily data. You run the Farmer and French 3-factor model, and for each stock you determine which has the highest estimated idiosyncratic volatility based upon the regression residuals, and then you basically buy those stocks that have the lowest idiosyncratic risk over in the last month, and you buy and you sell stocks that have the highest residual risk in the previous months. Yeah? That's basically a trading strategy based upon, or which is referred to idiosyncratic volatility strategy. Instead of the Farmer and French 3-factor model, you could also use just the CAPM model, yeah, and you would end up with the same results. Yeah? This is first this trading strategy, or this anomaly, if you want, is first documented in a 2006 paper from Ang and his research colleagues. Yeah? That's basically the idiosyncratic volatility strategy. So both strategies, yeah, so they're obviously related to each other, because the higher the maximum return over the previous months, the higher will be the idiosyncratic volatility, yeah, because obviously these are related strategies. So the betting against the volatility is basically taking into account these two issues, and they propose in the factor, and they basically propose a new strategy which they call the scaled max, S max, which is basically sort of takes these two issues into account, and this is a trading strategy that is long on stocks that have the lowest max, long on stocks that have the lowest max, and again the max is measured by the average of the 5 highest returns in the previous months. Taking these stocks that have the lowest max in the previous months and dividing it by the corresponding volatility, or ex ante volatility, and the short side of the strategy is then given by the highest max stocks over the previous months divided by the corresponding ex ante volatility. Yeah? And this trading strategy is referred to as Smax. So they argue that the corresponding theory that they test with the betting against correlation factor is the so-called leverage constraints. Okay? So they test they use this strategy here in order to test leverage constraints. Leverage constraints. So, and theoretically, it would be leverage constraints would suggest that this spread here between low and high correlation stocks should be positive, or we can say that the alpha, the risk-adjusted spread should be positive. This is what theory would suggest. And they also, from an economic point of view, they want to substantiate these results or their methodology by relating these leverage constraints to margin debts held by customers of NYSE member organizations. Yeah? So this spread here should be somehow correlated with margin debt held by customers of NYSE member organizations. Yeah? So why do they construct this, or what is the use of this Smax? So they want to test behavioral factors, behavioral factors, and it would also suggest if behavioral factors would drive this betting against the beta anomaly, then in this case this alpha of this strategy, of the Smax strategy, should be positive, right? Again, they want to substantiate this methodology by relating it to some economic driver, and they argue they aim at establishing a link between casino profits and or sales of lottery tickets in the UK, and they consider casino profits in the US versus lottery tickets in the UK, depending on the sample that they use. So this is basically what they do in their paper. Again, so the objective is basically to breaking down this betting against the beta factor into two different strategies, and by this testing if this betting against the beta spread is driven by leverage constraints or by behavioral factors. So the question arises, how do they construct the betting against the correlation factors? So first of all, they divide the overall stock universe. Let's again make our picture here. So we have the overall stock universe containing all stocks in the US. So of course in the paper they consider different samples. They have a global sample and the US sample, but as for now let's just focus on the US sample. So we have here the universe of all stocks in the US. So then you can divide the whole sample into volatility quintiles. So you have here, let's say, quintile 1. We have here the second group. We have here the third group, the fourth group, and group number 5. Can actually take away this. Yeah. So in the first group, we have the stocks that have the lowest volatility, and in the fifth group, we put in those stocks that have the highest volatility. So here we sort on the volatility. Well, in the middle, of course, there are the stocks that have a medium volatility. Then secondly, we can divide each group by the corresponding correlation. So again, we make a second sort where we have again 5 groups, 1, 2, 3, 4, and 5. And here we have, in the first group, we have low correlation stocks, and in the last group, in the 5th group, we have high correlation stocks. So here, in this dimension, we sort with respect to the correlation. So we have 2 dimensions, the volatility dimension and the correlation dimension. So what we can then do is, so for each quintile of the volatility, here for the first group, we can buy this group, where we have the stocks that have the lowest correlation, given we have also a subset of stocks that have the lowest, that are in the lowest volatility group. So we buy group 1 and we sell in this group those stocks that have the highest correlation. So that's our first portfolio.